Okay, so we got this 700 Newton guy. So I'm gonna put the forces on here. So look, boom, down. His weight, mg, is 700 newtons. That's not his mass, but by the way, we will need his mass. How do we figure out the mass of this guy? The mass of the guy, you're going to take 700 newtons, divide by 9.8, divide by gravity. His mass comes out as 71.429 kilograms. Okay, then the problem tells us that each arm exerts an upward force of 355. Okay? Each arm exerts an upward force, 355. So basically what we have here, to really simplify this down, here's what we got. We got an object, which is the guy. The total down force is 700 newtons. What's the total up force? 710. And then the problem tells us that he's going to lift himself 0.25 meters. That's the distance, or the displacement. All right, so what's the net force for this situation? Positive 10, positive being up. So the guy exerts a net force, there's a net force in the upward direction. Hey man, is the net force parallel to the displacement? Yeah, that's important for the work equation. Whenever you use the work equation, the force and the displacement have to be parallel. And we're fine, because the net force points up, and that's parallel to the 0.25 meters. All right, now look, you could solve this using last chapter, using just forces. What you could do is you could go, all right, sum the forces. You'd go 710 minus 700 equals ma, right? From there, you could solve for a. Once you have the acceleration, how do you finish the question? The question wants us to find his velocity at the end of his chin-up. As he goes up, what's the velocity at the end of the chin-up? So we could just use a kinematic, right? Find the acceleration, use kinematic. But don't do it that way, because now we're in Chapter 5. So how are we going to solve this Chapter 5 style? Well, the whole start of the homework set, you're going to be using the work net equation. So you can figure this out using work net. The net work on an object always equals the change of kinetic. Kinetic final minus kinetic initial. So the problem tells us that he starts from rest. So if he starts from rest, what's the initial kinetic? 0. There is no kinetic because he starts from rest. All right? Now, what is work net going to be equal to? Well, what's the basic work equation? The basic work equation is force times displacement. So if you're talking about net work, what will net work be? Force net times displacement. Right? That make sense? Okay. What's the equation for kinetic? 1/2 mv squared, where that's his v final. Okay? What's the only thing missing in there now? Do we know the net force? Yeah, it's 10. Do we have the displacement? Yeah, it's 0.25. Do we have his mass? Yeah. So guess what? We can solve for his final velocity. So doing the algebra, you're going to get 2 times F net multiplied by the displacement over the mass square rooted. So that's going to be 2 times 10 newtons times 0.25 meters divided by 71.429 kilograms. And then this comes out as 0.26 meter per second. And then just for fun, solve it force style. Free body diagram, sum the forces, get the acceleration, and then do a kinematic. You could also do it that way.